Logarithms. Yeah, I know. For a lot of us, that word just brings back bad memories of high school math, right? But what if I told you they're not what you think they are? What if they're not just about memorizing weird formulas? Turns out they're actually this super simple, really powerful way of seeing the world. So, let's do this. Let's finally demystify them together.
Okay, so first things first, let's just call out the elephant in the room. Why does this topic give so many of us such a hard time?
I mean, seriously, does just hearing the word log make your stomach clench a little bit? If it does, you're not crazy. You are so not alone. And there's actually a really good reason why.
And Adam Smith here really hits the nail on the head. It's not you, it's the way we're taught. We're forced to memorize all these steps and rules for shuffling equations around, but nobody ever stops to explain what a logarithm actually is. We never get that aha moment, that deeper meaning.
Yeah, does this look familiar? I bet it does. This is what we all think of, right? All these exercises about how to expand this, how to solve for x. Well, for this explainer, we're just gonna throw all that out. We're not gonna talk about the how. We are gonna focus 100% on the why.
All right, let's get to the good stuff. The one, single, simple idea that changes everything. I promise you, once this one concept clicks, the whole world of logarithms just opens up.
Okay, here it is, the big secret. A logarithm is just a way to talk about the scale of a number. That's it. It's not about the exact number, it's about how big it is. What's its order of magnitude? What ballpark are we playing in?
Okay, to really get a feel for this, let's start super simple. Just think about the single-digit numbers, 1 through 9. They're all different, of course, but they're kind of in the same club. They're playing in the same league, on the same scale. But then you hit 10, and now you're in the world of two-digit numbers. And it's a totally different game, right? The number 87 just feels like it's on a completely different level than, say, the number 7. It's on a whole new scale. And then, of course, we make another huge jump to get to the three-digit numbers. And once again, they are in a class all their own. A whole new scale, an entire order of magnitude bigger than what came before.
And this is where it all comes together. See, the math just formalizes this gut feeling we have. The whole number part of a logarithm, in base 10 anyway. It's basically just telling you how many digits are in the number minus 1. So, any one-digit number, its log is going to be 0 point something. Any three-digit number, its log is 2 point something. You see the pattern? An 8-digit number is going to have a log of 7 point something. The logarithm literally is the scale.
Okay, but so what? Why is thinking this way so useful? Well, let me show you a classic example that makes it crystal clear.
So let's say you want to make a chart comparing the size of things in our solar system. If you do it the normal way with a regular linear scale, you get this. The sun is so unbelievably massive that every single planet, even a giant like Jupiter, is just this pathetic little speck you can't even see. I mean, this chart tells us nothing. It's completely useless. But what happens if instead of plotting their actual size, we plot their scale? We plot the logarithm of their volume. Look at that. Bam! Suddenly, it all makes sense. You can actually see the difference between Jupiter and Saturn. You can compare them to Earth. We can see how everything relates. By just changing our perspective to focus on the scale, we've taken total chaos and turned it into perfect clarity. Okay, so now that we've got the gut feeling, the core intuition, we can take a quick peek at the formal math. And don't worry, it's not scary anymore. Just think of it as the grammar, the language we use to talk about this idea of scale. All right, this is the thing you see in every textbook. And it looks complicated, but all it's really asking is a simple question. How many times do you need to multiply the base number by itself to get your target number? That's it. So for base 10, the question is just how many 10s do you need to multiply together to make this number? Which, if you think about it, is just another way of asking, what's its scale?
Now, you can technically use any number as a base, but in the real world, we really only use 3 main dialects. There's base 10, which we've been using. It's perfect for human stuff, things we measure. Then there's base E, the natural log. That's the language of growth and nature. And finally, there's base 2, which is the language of computers. It's all about asking, how many times do you have to double something?
And here's the cool part. Once you get this idea of scale in your head, you'll start seeing logarithms everywhere. Seriously, let's do a quick rapid-fire round of where this stuff pops up. You've got earthquakes on the Richter scale, the loudness of sound on the decibel scale, acidity using the pH scale, even things like photography exposure and radioactive decay. They all use this language of scale because they have to measure things that cover these gigantic ranges.
And this is the key takeaway. On all of these scales, when you go up by one number, you're not just adding 1, you're multiplying. A magnitude 6 earthquake isn't just a little bit worse than a 5, it's 10 times more powerful. A pH of 3 is 10 times more acidic than a 4. That is the incredible power of thinking logarithmically.
Okay, to wrap this all up, let's talk about one of the most important, but maybe hidden, places logs show up, our digital world. This is all about how logarithms make computers and the internet blazingly fast. So picture this. You're searching for a word in a massive dictionary with millions of entries. The slow way, a linear search, is to start at A and check every single word. It would take forever. The smart way is a binary search, and it's logarithmic. It's so much faster it's not even funny. Because it's not about adding more work, it's about dividing the problem.
And it's so elegant and simple. Here's how it works. You don't start at the beginning. You jump right to the middle of the dictionary. Is that your word? Probably not. But now you know if your word comes before or after it. So, bam, you just threw out half the entire dictionary in one step. Then you just do it again with the half that's left. Jump to the middle, throw out half. Every single check cuts your problem in half. That amazing having power is what a logarithm base 2 is all about. It's just a beautiful idea, and it's literally why you can search Google and get results in an instant.
So you see, logarithms aren't some scary abstract thing from math class. They're a tool, a way of seeing. They let us make sense of a world that has these insane differences in scale, from planets to protons. They make the incomprehensible comprehensible. Because at the end of the day, all they are is the language of scale. And that kind of makes you wonder, right? What other huge, complex problems could we understand a lot better if we just learned to look at them through a logarithmic lens?